In this video, let us see about the doubly linked list. So the doubly linked list is otherwise called as a two-way linked list. So you will have the node represented like this. So say that the data part contains the integer value, okay, and there are two parts in the node. One is called as the next field and other is called as the previous field. So this next will point to the next node of the doubly linked list, and this previous field is used to store the address of the preceding node. So this will enable us to traverse in the backward direction. So generally for a single linked list, we have seen only the forward direction. Say that this is an example of a single linked list, we had only one direction. But whereas in the double linked list, we'll be having both forward direction and the backward direction, so that the nodes can move in forward and it can even we can traverse in the backward direction. So traversal can take place in forward and the backward direction in the case of the double linked list. So now let us see one simple example for a double linked list and what is the constraint in a double linked list. Okay, so let us consider a double linked list. Say let us write down 1, 2 and 3. So 3 nodes. So the constraint is that the last node of the circular linked list, the next pointer of the last node of the circular linked list will always point to null. This is the first constraint. And the second constraint is the first node of the double linked list. Generally we call it as start, and the start node's previous pointer will always point to null. Okay, so start's previous is always pointing to null. Okay, and your last node's next pointer will always point to null. Okay, so this is the second constraint. Okay, so generally what does it mean? So there is no previous node before the first node and there is no node after the last node. So this is how you represent a double linked list. Okay, so when we have to implement with C programming, so how do we have the node structure? So struct node, we write down the data part, so int data, and then we'll create the next pointer and the previous pointer. So both next pointer and previous pointer will point to the same node structure. So it is a self-referential structure. Okay, so the previous pointer will point to the node, and we'll have a pointer variable called as next, which will point to the node which is having a same structure. So this is how a node structure is represented for a doubly linked list. Now let us see the insertion operation in this video. So how to perform the insertion in a doubly linked list. So insertion, there are various cases. The first case, let us insert the node at the beginning. So how do we insert a node at the beginning? So say that we have a doubly linked list. So 1, 2 and 3. Okay, so I'm marking the of the doubly linked list as x. Okay, the next point of the last node is x, and the starting node's previous pointer is pointing to the null. Okay, so this is my start. Fine. So now we are supposed to insert what? A new node at the beginning of the doubly linked list. Say that the new node which I have to insert is 4. So since it is at the beginning, you know that if it is going to be the first node, always the previous pointer of the first node is going to be null, right? So first let us start writing down the pseudocode. Okay, and we have to build up the connection between this new node with the start, and then from the start to the new node. So we'll write down now the pseudocode. So what is going to be my step 1? So step 1, if it is for any insertion, hope you can remember from the last videos. First we have to check out now for what? The available memory. So first write down whether avail is equal to null. If avail is equal to null, what does it mean? There is no memory, right? So if avail is equal to null, it means it is an overflow condition. Yes. Okay. Now what is going to be our step 2? Now from the available space of memory, okay, you have to create the new node, right? So how do you create the new node from the available space? You write down new node is equal to avail, and now you make the avail which is being used by the new node to now point to this next free space. So how do you write that? Avail is equal to avails next. Okay, fine. Now let us create the new node. So for the new node, I am supposed to create what all part? The data part. And now I know as it is going to be inserted at the beginning, it is the previous pointer for the new node is going to be null, right? So we'll write down now. So we'll write new nodes data part will now be equal to the value, say 4, and my new nodes previous part is pointing to null. Okay, and now we'll write down what should be the connection here. The new nodes next should now point to whom? The start, right? So we'll write down the new nodes next is now pointing to whom? The start. Yes. So we have made connection only for this forward direction. Now for the backward direction, how can we make out what is this? This is the starts. So let us write down the step 4. So step 4. So we make out the start nodes previous pointer to point now to whom? The new node, right? So start. So this is the arrow. So starts previous has now pointing to the new node. So we have written for a way connection forward and backward direction. Now as it is inserted at the beginning, now new node should now become what? The start, right? So we will now make the start to point now to whom? The new node. So this is going to be the new node is now going to be the start. So how do we write that? So in step 5, now we will make the start as the new node and then we will exit. Okay, so this is how the insertion is done at the beginning of a doubly linked list. Now let us see how to perform the insertion at the end of a doubly linked list. Insertion at the end. So let us take out an example. So say that 1, 2 and 3. Okay, so this is the simple doubly linked list which we have considered. And we have to insert now what? The new node at the end of a doubly linked list, right? Say that the new node which I have to insert will have a data part 4. Okay. Now what is the constraint if the node has to be inserted at the end? If it is a last node, what will be the last node's next pointer? The next pointer will always point to null, right? Yes, hope you can remember it. Now can we start writing down? So we have to establish a connection between the last node of the already existing linked list with a new node and from new node to the last node of the already existing linked list, right? So let us now start writing down the pseudocode. Okay, so now step 1. So let us write down the variables called as start and then ptr. Okay, fine. Step 1. Now check out for what? Available memory. So avail is equal to null. If avail is equal to null, what do you write? We write down as it is an overflow condition. Now what is my step 2? I have to allocate the memory for the new node. So how do we allocate? New node is equal to avail, right? and now I make the while to point to its next free space. So while is equal to while's next. Okay, fine. Now, what is my step 3? So step 3 is, now I'll write down the new nodes data part. So new nodes data part, we'll assign it with the value. So let us write down the new nodes data. We'll assign it with a value, and we know what is going to be the new nodes next part. So let us write down the new nodes next is now pointing to what? Null. Okay. So now we have to, what is our objective? We have to connect this new node with the already existing list, right? So we have to make use of the variable called as start and PTR. So we'll assign the PTR with the start, okay, and let us start traversing. So what is the condition for traversing? Until I find my PTR's next pointing to null, until this position I have to traverse, right? So when I find that my PTR's next is equal to null, then I make out the connection. So if it is not equal to null, what do? I make my PTR to traverse to the next nodes, right? So what is the condition? So step 5. So how do we write step 5? While the PTR's next is not equal to null. If PTR's next is not equal to null, what do we move? We make the PTR to move to the next nodes. Okay, fine. Now this condition has failed. Okay, the PTR, the pointer variable, has come to the last node of the existing linked list. Okay, and now what are you supposed to do? So if the condition fails, now writing down the step 6, you should make out the connection between the last node and the new node. So how do we make out? So how do you call this? This is PTR's next. Okay, so we make out the PTR's next to point to whom? Who's this called as new node? Okay, and then what should be the connection for this backward direction? So this is called as a new nodes previous, right? So this is the new nodes previous. So how do we write that? The new nodes previous should now point to whom? The PTR. Or even you can write down the new nodes previous is now pointing to the PTR's next. Okay, so this is all about the inserting a node at the end of a doubly link.